So now that we've worked with solving whole number real equations for quadratics, we're also going to look at what's called the imaginary number. So before we couldn't take the square root of a negative, now we can. We've created something called imaginary numbers that are the square roots of negative numbers. So these are written of the form bi, where b is a non-zero number, and I, called the imaginary unit, represents the square root of -1. So I is the same thing as the square root of -1. And it's important to notice this, and we write our i's a little weird, kind of backwards here, just so that we can differentiate them from other units. So this is different ways we can write it. Notice that when we have it with a square root, we usually write it in front, just for clarity. Now, since I is the square root of -1, that means that I squared is equal to -1. So the square of any imaginary number is a negative real number. So we can use that property of exponents later on here to help us out. So if we want to find the square of the imaginary number, we have to break it apart. So if we want to take 5i squared, that means we need to take 5 squared, and we need to take I squared and then multiply them. So 5 squared is 25, and I squared is -1. Multiply those to get -25. So in the case of part B here, so if we take -I times the square root of 2 squared, you can see they've already pulled out the I squared. That means we have to take what's left. Well, that's -√2, and we need to square that. Well, √2 times √2 is just going to be 2, and the negative times the negative makes it positive. So we'll have a +2 there. 2 times -1 is -2. So by definition, I is the square root of -1. Does -1 have another square root? Well, we always say that a number has a positive and a negative square root. So if we take the square root of 4, it has two solutions, plus or minus 2. So if I is a solution to the square root of -1, that means -I would also be a solution because it is the negative portion. So let's try some more. We want to find the square of the imaginary number. So if we take -2i squared, it's the same thing as taking -2 squared times I squared. -2 squared is +4. I squared is -1. So our answer is just -4. Something a little trickier here. We've got √3 over 3i squared. So again, we break this up into √3 over 3 squared and I squared. Well, √3 over 3 squared, we have to square both the numerator and the denominator. So we take √3 squared, gets us a +3. Our denominator here, we take 3 squared, gets us 9. I squared, again, is -1. So we can reduce 3 over 9 is 1/3. Multiplying by -1 gets us an answer of -1/3. So using imaginary numbers, we can solve these simple quadratic equations that don't have real solutions. So like we did before, we isolate the squared term. So in this case, we subtract 12 from both sides. Then we take the square root of both sides to get plus or minus square root of -12. Again, this is where we do a factor tree. 12 is made up of 4 and 3. 4 means we can pull a 2 outside the root. 3 has to stay inside, and then we'll also pull an I outside. So our solution would be plus or minus 2i times the square root of 3. So let's do that again. So we have to subtract 11 from both sides. That leaves 4x squared is equal to -5. Divide both sides by 4 to get -5 over 4. So that means we take the square root of -5 over 4. So if we have square root of -5 over 4, we can break that apart. We can immediately pull an I outside since that's the square root of -1. That leaves us with the 5 over 4 inside, which we can break apart into √5 over √4, which would get us √5 over 2. So that's our answer here is I times √5 over 2. So let's try a couple more of these. So again, we want to isolate our squared term. So we'll have to subtract that 9 to the other side. Multiply by the reciprocal, that's 4. That gets us -36. So x is just going to be plus or minus square root of negative 36. Well, again, we can pull that I outside, and the square root of 36 is just 6. So our answer would be plus or minus 6i. Over on the right here, we subtract 3. So negative 5x squared is equal to 7. Divide by negative 5. Take the square root. Get plus or minus negative 7 over 5. So I can immediately pull that I outside. And I know I can break it apart into root 7 over root 5. So since I have that root in the denominator, I do need to rationalize, multiply by root 5 over root 5. So this should give me the solutions plus or minus I. In the numerator, root 7 times root 5 is the same thing as root 35. And then in the denominator, I'll just get a positive 5 there. So the quadratic equations 4x squared plus 32 equals 0 and 4x squared minus 32 equals 0 differ only by the sign of the constant term. So without actually solving the equations, what can you say about the relationship in their solutions? So the first answer will have a negative, an imaginary solution, because when you subtract the 32, you'll end up with a negative 32 on the other side. So the first one has imaginary solutions, and then the second one will have real solutions. And they'll both then just vary by I. Since the number is the same, just one is negative, one is positive, they'll only vary by I. So what kind of a number is the square of an imaginary number? It's a negative real number. Negative real number. Number I, just as itself when we squared it, comes out to negative 1. So anytime we take the square of an imaginary number, it's going to become a negative real number. So why do we reject negative values of t? We are excluding time before the fall starts. So then if we want to describe how to take the square roots, how to find the square roots of a negative number, find the positive solutions, and multiply by I.